So here's the Modbus protocol. Based upon this information, we can go ahead and determine what type of traffic is coming into our industrial control system and determine whether or not any of it is malicious. So you can see here's the sequence number and here's the acknowledgement. This is the way it makes sure that the packet actually arrives.
So hey everyone, I'm Yaniv Hoffman, and today I'm here in Hong Kong, as you can see behind me. And I'm really excited to join forces once again with Master Hacker Occupy the Web. And we are diving into Wireshark today, one of the most essential tools in any hacker or security professional toolkit. Even after all these years, it remains the go-to for analyzing packets, spotting intrusions, and really understanding what's happening on the network. So let's jump right in. OTW, take it away.
Thank you, Yaniv. I really appreciate your invitation to be on your show once again. And as you said, Wireshark, when I make a list of essential tools that everybody in cybersecurity must know, we did a video on Nmap, and that's one of those tools that everybody must know. Well, I think Wireshark is one of those tools as well. You know, it's been around for over 20 years now. And it's the gold standard in packet analysis. There's other tools that do similar things to Wireshark, but it's still considered the gold standard. And I think for those people who are out there who are looking at a career in cybersecurity, it's one of those tools that you really need to have on your resume. It's not very difficult. It's pretty simple to work with. So I'd like to spend a little time with it today. And it's not just for cybersecurity people either. You know, every network engineer needs to know Wireshark. And I would say everybody in IT probably needs to have some experience with Wireshark.
But before we dive in, a quick note, and most of you watching right now aren't subscribed. And this channel isn't sponsored. I fund it myself, driven by my passion for cybersecurity and sharing these stories with you. If you are enjoying the videos, only if, and want to see more, it just takes a second to hit the subscribe button, like, share the video. It really helps me keep going. Now, let's get into it.
So with that having been said, I'm going to be running Wireshark in Kali, and let's take a look at it. All right. So I'm running it in Kali. Those of you who are running in Windows and a Mac and basically any other environment can run Wireshark as well. It's one of those tools that has been ported for just about every platform. If you're running in Kali, then or any Linux distribution, you can simply go ahead and just type sudo Wireshark. Right, sudo Wireshark, and that should open up Wireshark. Got to give it our password. And this will go ahead and open up Wireshark. So here you can see it. So when it opens up, you can see it's going to give us choices as to what interface we want to capture from. Right? And you see the very first choice is ETH0. That's the Ethernet adapter. Or any, and it has a few others, has a Bluetooth, and every system is going to be different based upon what interfaces you have. Right? If you have a Wi-Fi adapter, it's going to say WLAN 0. Or you can just click on any, and that's going to capture all the traffic. You can see here this little graph of data passing tells us that these are active. So we click on the other ones, you see there's no activity on it. So let's go ahead then. In most cases, most people are going to use the ETH0. If you're using Ubuntu or some of the other Linux distributions, it might be a slightly different designation for the Ethernet adapter. But you should see this type of activity taking place here, and that's this, here's where the packets are coming from. So let's go ahead and double click. All right. And away we go. Okay, so what's happening here now? All right. Well, let's go ahead and just do this. There we go. Now we got a full screen. So what we're doing is we're seeing packets come across in real time. This is it's a VMware image of Kali. So you can see there's some references in here to VMware. You can also see that we have the source IP address, the destination IP address, and the protocol. So the first thing it does is it goes out and does some ARPs. You see these ARPs right here, right? This is the ARP protocol. And then it's going and do the network time protocol here, right? And there's some more ARPs. And then you can see that there's starting to be some traffic, okay, that's TCP based. So this is real time that's going on up here. This is what's really happening across the wire. Down below here, we have the ability to click on any packet, right, and then be able to tear into the packet, right? Tear into the packet to see what's actually going on in each of those packets, right? So we can click any packet and it'll pull it up here. And then this allows us to dissect it. That's probably the best word for it. We're dissecting the packet. And I think it's important, for those people who really want to be able to use Wireshark, you have to kind of know the protocols, right? And most of what we're dissecting is going to be TCP. You can see a lot of traffic going across here now. And so you need to understand a little bit of TCP and IP protocols. And then over here, this is the contents of the payload in both hexadecimal and in ASCII. We've got more of these ARPs going. This is real time that's taking place, right? So if we wanted to go ahead, we see in all this traffic going across, and sometimes it gets, here it is, this is really busy now, right? Sometimes you don't want to see all this traffic, right? You only want to see a fraction of the traffic because there's too much information. You're looking for something that's maybe malfunctioning. You're looking for malware. You're looking for attacks. These are all the things that you can use Wireshark for. And so you have right here what's called the display filter, right? And so up here, we can go ahead and put in any of the protocols, right? And to give you some idea, Wireshark is really, really useful for, analyzing just about any type of traffic. And people might not realize how many different protocols there are. But if you go up here to analyze, and there's a right here, it's called display filter expression, right? And this helps you to build your own filter. And if you do that, let's just quickly go there. You can see how many protocols there are. Look at this. This is just the A's. there are so many protocols. There's so many protocols. It starts off and ends up with Zigbee at the end, which is kind of a good way to segue into our we have an upcoming smart home hacking class coming up, and we're going to be doing a lot of Zigbee, because Zigbee is used in a lot of smart homes. But this gives you some idea. You don't have to understand all of these protocols, but understand that there are a lot more protocols than just HTTP and TCP. So we'll come back to this in just a moment and show you how we can use that. But the first thing we want to do is just go up here to the display filter, right? And we can just go put in, say, well, we saw a bunch of ARPs go across. We can see some more coming across now. We can just filter for ARP and just go ahead and type it. And notice that this line becomes green. And that tells us that we have the proper syntax to be able to filter for ARP. And so then once we do that, we can just hit enter. And now you can see that rather than seeing all of that traffic, we see just the ARP traffic. And you can see there's quite a few packets of ARP, right? And then we can click on any one of those, and then we can bring up, additional information and allow us to dissect each packet. And as the viewers know, ARP's used to be able to map IP addresses to MAC addresses. And all that information you can see by dissecting each one of these packets, right? So, we probably more useful is to do TCP, right? We'll go TCP, and now we see all the TCP traffic. And we can begin to take one of those packets. Okay, here's one that goes to 34.107.243.93. Click on it, and it goes ahead and gives us, all the information. All right. So we can go down here and look at Ethernet, and it tells us a destination, and there's It tells us the type, it's IPv4. It tells us the sources from VMware. It tells us the stream index. And then we can go expand the Internet Protocol. We can see there that it's Internet Protocol version 4, not 6, but 4, which most of us are still using after all these years. Right? And then you can see more information, looking for various. Here's the source address, the destination address, right? Shows us the port, destination port, source port, destination port. So a lot of good information of being able to analyze this traffic. And it's very easy to find the information and analyze it so that if you're having an issue, if you're having, say, an attempt on your particular system or your network, you can just go ahead and turn on, the Wireshark and then begin to look at the traffic. And you don't have to go ahead and look at it in real time. It's possible that you can just turn it on and it'll capture all the packets for you. And then you can analyze afterwards. But there's there's so much capability in this particular tool. So for instance, say that we were looking for, let's say we were looking for a particular IP address. We could go IP.addr, right? Mm-hmm. So that allows us to look for a specific IP address, right? So you can see there's a lot of traffic from 34, 36, 137, 203. So we can just go ahead and it uses it uses the double equal sign, right? And then we can go ahead and search for all the traffic from 34, 36, 137, 203. And you can see there's a lot of traffic, okay? Yeah. And you can see the various protocols. So we just said this IP address. Now, we didn't say destination or source. We just said either direction. And you can see it's giving us either direction. And you can see here that it's the quick protocol, right, that most of the browsers are using, right? And so we can see some TCP and TLS, and so we can go ahead and look at all of this traffic, and let's go ahead and click on one, right? And so down here we have it in hexadecimal. This is the payload, okay, and then this is an ASCII over here, and we can go through this entire packet and begin to look for. Now here it says protocol TCP or number 6. So TCP is the number 6 protocol, right? Source address, destination is my local IP address. We also might want to look at certain things like flags, right? So flags in TCP are a way that TCP uses to communicate what their intentions are. So if I wanted to, for instance, open a connection, all right, that's a SYN flag. If I want to close a connection, that is a FIN flag. Remember, there's 6 flags on TCP. So we can search for those flags. So for instance, if we wanted to find all of the SYN flags, right? I'll show you 2 ways that we can do it. We can let's go up here to Analyze and do display filter expression. For those people who are just starting out and don't necessarily remember all of the filters, this is the way to go, is display filter expression. So we click on it, and then we can go down to TCP, right? Let's go all the way down to TCP, down further and further. Here we go, TCP. All right. Transmission Control Protocol, right there. All right. Now, these are all of the fields that we can search for. All right. Lots of various fields. I bet you didn't know there was this many fields. There's so many fields. Not you, but anybody in general. And so one of the things we might want to look for are flags. So here's the flags. And so, for instance, if we wanted to look for all of the flags that open a connection, that would be TCP flags SYN. If we click on this, okay, it ends up creating a filter. And it's TCP flags SYN equal 1. And then we can go OK. And now if we hit enter, notice that it's green, right?
Yeah.
And if we enter, we've filtered out everything except those packets that are opening a TCP connection, right? Remember, it has a SYN flag, right? We could also go ahead and look for, say, FIN flags, right? FIN, those would be closing a connection. And there you go. You have all of these packets that are closing connections. It's a really powerful tool to do this type of analysis, but you have to know a little bit about the protocol and what you want to search for, right? So there's so many fields, and we can go ahead and say, say we're having a DNS issue. Let's say that our DNS is failing us, or it's being has a DDoS attack against it. We can just enter in DNS, and now we can see all of the packets that are DNS. Okay, you can see that they're standard query, right? From Mozilla, Cloudflare. There's a lot of information here. And so we could break down any one of these packets. It's also important to note that you can also you can search by port, right? So you can go port. All right, let's go TCP port. Okay, so it's not just port, TCP port. And let's go equal, say 443, right? Right, there we go. Now we see all of the HTTPS traffic, right?
So I have a question, OTW, on this. Now, today, there is encryption everywhere, right? HTTPS, as you show, quick, as you showed before, DNS over HTTP. So where does Wireshark still provide real value for investigators? And how do you extract the insight from the traffic you cannot really decrypt?
Well, you can't decrypt. In some cases, the traffic is not encrypted, but in most cases where it is encrypted, this is all header information, right? Yeah. Right. So the header information is not encrypted in most cases. In some cases it is, like in the VPN. Some VPNs will encrypt the header information. Yeah. But this comes out of the header of the packet. So remember that in TCP and IP, there is all this information that's in the header of the packet. Maybe I can open up a diagram. Let me do that and show people what I'm talking about.
Yeah.
So if you're not familiar with that, give me 1 second. All right, and I'll pull up a nice diagram of TCP. Also, I will point out that all of this information is in my Network Basics for Hackers course and book. All right, so if you don't get all of this today, okay, here, let's go ahead and take a look at this. So I'll expand it. This is a diagram of the TCP/IP header. Right? So this is the information that we're looking at over here. So the version, the type of service, the total length, the identification. Here's the flags in the IP header. Now, this is different than the flags in the TCP header. This flags right here is for the fragment, don't fragment. Right? So IP tracks fragmentation, and so if a packet gets fragmented, it doesn't lose it. It just knows, oh, this packet has been fragmented, and then it sets this flag, okay, it's called MF, more fragments, okay, and then when that happens, the receiver at the other end will wait for the fragments to come and reassemble them, right? And so that's what these flags are about here. These flags over here, this is TCP and this is IP, right? So most often in our communications, we're using both protocols together because the IP packet, the IP header, has both the source address and the destination address, but it doesn't have port. That's included in the TCP. Here's the source port and destination port, right? That's what. So we have to use the two together to be able to communicate effectively, both the port and the IP address. So this flag here is for fragments. Okay, here's TTL, time to live. This is how many hops the packet can go before it's exhausted. Time to live. Here's the protocol. In this case, the protocol is 6, which is TCP. So IP can be used in conjunction, bonded to multiple protocols. And that's where this comes into play. Okay, so it's not just TCP. It can be used in other protocols. And so in this case, where it's bonded or used together with TCP, over here, we go back down here, we can come back here, and you can see protocol right here. There's TCP number 6. Here's the time to live, 64. That means it'll go 64 hops before it's exhausted, and it will stop looking for the IP address that's being sent to. So, as you know, and is that the packets are sent across the internet, and they go through multiple hops. And if it doesn't find its destination by the TTL, and the TTL can differ for different protocols, okay, and by different operating systems. And so in this case, it's set to 64. And if it doesn't find its destination in 64 hops, then it just dies, right? And it doesn't arrive where it's supposed to. So this is all the information that we can gather, from each one of these packets. Now, we're not talking about the payload, right? We're not talking about the payload. The payload is often encrypted, but the header is not. All the information that we're getting here, right, is all off the header. You can see that there's a TLS, and so we are using encryption here. Here's TLS 1.3, TLS 1.3, but it's encrypting the payload and not the header. All the header information is available to us right here. So this is TCP port 443, which is HTTPS, right? It's encrypted, but the header information is still available to us, although the payload will be encrypted. So we can't read, but we can tell a lot from just what's going on in the header of these packets. We don't have to read what's inside the payload to be able to see there may be a problem. There's a lot we can do by just looking at the headers of all of this data. Now, here's a good example. You can see it's in red right here. These are all color coded. This is bad TCP. It comes out in red like that. Right? There's something wrong with that packet. Right? You can see it has a reset flag on it. That's the way that that's the way that TCP communicates that something's wrong or close. So if I send a packet to a port that isn't open, the receiver will send back a packet, okay, that has a reset that says, okay, you're in the wrong place. We're not open for business here, right? So this is the way that TCP communicates. And it's really kind of fascinating if you're not familiar with it, and your viewers aren't familiar with it, how these systems actually communicate. And this was all developed like 40 years ago, 50 years ago. And it's really a relatively simple system. Here you can see the acknowledgments. Okay, this is where we have we've established a 3-way handshake, and we can see the ACKs, and here's a SYN-ACK, and here's an ACK, and ACK. Right, so all of this information is available to us, right? But we can also say, for instance, we were looking at DNS just a minute ago, so let's go ahead and we all know that DNS is on port 53. So let's go ahead and look. Oh my goodness, there's no DNS. How could that be? Well, as we know, okay, or maybe not, DNS queries, when you're going ahead and sending out to a DNS server, it uses UDP. It does not use TCP. So if we just go ahead and look for DNS, we'll find lots of DNS because it's UDP, right? So if you go ahead and ask it for TCP port 53, you're not going to get anything because this is all UDP traffic. DNS does use TCP when two DNS servers are communicating, right? When two DNS servers are communicating, then that uses TCP. When you or I are simply going ahead and trying to do use DNS to be able to find the IP address. So that's what DNS does, of course, is it just goes ahead and it maps a IP address to a domain. And so every time we go from one website to another, we have to do a DNS query, right? That's what all of these are. See, standard query. This is all UDP, right? And so you're not going to find it if you just go on port 53. So there's a lot of interesting things that we can do with it. And we can often find, where packets are coming from. So if somebody's attacking us, we can go ahead and look at at least what IP address the attack is coming from. Oftentimes we might want to say, for instance, see whether or not there's a command shell going out of this system, right? And so there's lots of different things that we can do. I'll show you a few quick searches that we can do that are really useful and that are useful in analyzing problems on your system. Well, I mentioned earlier the idea of fragments. Let's take a look see if we find any fragmented packets here. So let's go. Remember that it's IP, okay, that tracks the fragments, okay, not the TCP. So it's IP flags, okay, .mf. Now, it used to be, and still sometimes is, that attacker can get past some of your endpoint detection by simply fragmenting packets. Right? Fragmenting packets, I can take my packet and purposely, as an attacker, I can purposely fragment it. And we've seen this being used recently in UDP fragmentation. So we've seen effective DDoS attacks using fragmented UDP. And so one of the things that we might want to look for is fragmented packets. So let's go ahead and go right there. And let's see if we can find any IP packets that are fragmented. None. Yeah. All right. So if we found some, that would, it would kind of raise some issues in your mind. Right? And if we see a lot of them, then it might be a part of an attack. Right. So then that's one thing that we want to do. We looked at the flags in TCP. We can look at any of the flags, the 6 flags, right, to be able to track what's happening. Now, let's see. What else do we want to show you here? We can go, let's say we want to look for HTTP traffic. Let's go do that, right? HTTP. Just type it in. You can see there that, and we're not getting any HTTP. Let's go ahead and create some HTTP traffic. All right. So let's go to everybody's favorite website, Hackers Arise. And when we do that, look at what we have. We have some HTTP traffic. This is HTTP 2. Let's try HTTP 1. Here's HTTP 1. So for your viewers who aren't aware, there's like 3 versions of HTTP. And you and I did a video on HTTP 2. It was being used for DDoS attacks. So that's something that you might want to take a look at. So if you're having an attack or appears to be an attack, you might want to take a look at, HTTP 2. Oh, we don't have any HTTP 2. Do we have any HTTP 3? No. So all of our traffic that we've generated is this HTTP 1. And let's go ahead over here and look at some of this traffic. And so over here, this is where we can dissect the packets. Over here, you can see that it's identifying the user agent. So the user agent defines basically who the user is, who's trying to connect to your website. This is every time you're using a browser, okay, and sometimes other things as well. It'll have a user agent attached to it that tells the server what operating system and what browser you're using, and other information as well that it uses to be able to find the best way to present the information. So that different browsers and different operating systems use the information that comes from a website differently. So this is what the user agent does. The user agent can also give a lot of information to the server about who you are. And I have a tutorial on Hackers Arise on the fingerprinting that can be done based upon user agent and other information. You can also see here it says HTTP 1.1. It's a post. So all this information is available to us, from just one packet that is available to us. So that's HTTP. We can look for additional information that might be helpful in an analysis. So if we have something going on in our network, we can search. We did a search by IP address. We can search by protocol, whatever the protocol might be. So for instance, one of the things that we have a class coming up soon on SCADA. All right. SCADA is an industrial system. That's one of the things that we specialize in at Hackers Rise is industrial control systems, both the hacking and protecting. So we have both a forensics class coming up in SCADA, as well as an advanced SCADA class coming up. But one of the most popular protocols, the most popular protocol in SCADA is Modbus. Now there's hundreds of protocols in SCADA, and it's one of the things that makes it more challenging is there's so many. Let's go down and look at all the way down to Modbus. Like I said, there's about 200 protocols. There it is, right there. So here's the Modbus protocol. Right? We're probably not going to find any of these on our traffic here right now because this is not an industrial control system. But based upon this information, we can go ahead and determine what type of traffic is coming into our industrial control system and determine whether or not any of it is malicious. There's a number of ways that we can do this. Modbus actually has a different way of communicating than TCP and IP. And we can analyze it based upon these various values in its header, right? Mm-hmm. So, and then let's go back to HTTP, okay, and do a little analysis on HTTP. Let's go find our HTTP protocol and see all the fields that we can analyze. Here it is right here. All right, here's all the fields that we can analyze HTTP for. Right? So we can check for cookies right here. Mm-hmm. And look for cookie pairs, the date, whether it's been reassembled or not. So let me go back to my picture of TCP/IP. And we talked about, this is kind of this basic TCP/IP. We talked about fragments right here, and we haven't found any fragments. Right? But notice here that we have sequence numbers and acknowledgement numbers. This is a way that TCP makes certain that the packet arrives, right? These sequence numbers and acknowledgement numbers. And we can see, if we go back to our analysis here, let's pick a packet and we'll go to our TCP right here. And you can see all the key information. Can you hear the church bells in the background? Yeah. So you can see here's the sequence number and here's the acknowledgement number. Mm-hmm. What these do is it makes certain that the packet actually arrived. So the client sends out a sequence number, and that's what this is here. And if it doesn't get that sequence number back as an acknowledgement number within a specified period of time, it resends the packet. So these are important, okay, in being able to make sure. That's what TCP is, connection oriented. Everybody teaches that, right? Connection oriented. This is the way it makes sure that the packet actually arrives, right? This is not something that UDP, for instance, has.
Yeah.
So this is kind of TCP 101, but there's a lot of really useful information, right? That's in each one of these packets that can help us to determine what type of situation we're dealing with. And of course, if you're a network engineer, you can go ahead and use this to be able to analyze, for instance, what's going on in your system.
So OTW, when analyzing a real incident, what's your step-by-step approach inside Wireshark to move from the raw packets to identifying the exact problem or compromise or malicious sector?
Well, first of all, what I would do is I would look at the data up here and see where most of the so let's assume and say it's a DDoS attack or a DOS attack. One of the things that I would look for is I would start to look for what protocol was being used, right? So, there's some old DDoS attacks that use, for instance, ICMP. That's ping, right? The old ping of death and what have you. And there's no ping, but I can create some ping. Let me do that. All right. So I'm going to go open up another terminal, and I'm just going to go. I'm going to go ping 8888. Right. And you can see now that I've generated. Start seeing the ICMP. Right. So if I was seeing a lot of ICMP on my system, and this would be one of the things I want to look for. So I first of all want to get some idea of what protocol. And then of course now I have, the source IP address and the destination IP address.
Mm-hmm.
So that would be one of the things I would look for. I could, do the same thing for various protocols. I might want to look at what's happening, for instance, to my I might want to look at, for instance, an ARP attack against my ARP, right? So I could look there and see if there's anything that seems amiss in my ARPs, and everything looks like it's pretty normal traffic. We might want to look at, for instance, DNS and see what's going on there.
Mm-hmm.
And look for anything that looks unusual here. If we have an attack coming from, say, a bit of malware, right? If we can go ahead and look for, let's go look at TCP, right? And likely it's going to come from TCP, and we can go through each one of these packets and then filter, right, by the IP address and start looking at the various packets that are coming, okay, from that particular IP address. So let's go ahead and create a filter. Let's go IP address. Let's go .addr equal, and then we'll just pick out one of these IP addresses here. And we looked at this earlier about how we can go ahead and filter, right, for traffic coming from a particular IP address.
Mm-hmm.
And then, of course, once we have an IP address, we have a suspicious IP address, we want to go ahead and maybe find out more about that IP address, right? Find out what country it's in, what domain it's associated with. And so this is one of the ways that we can go ahead and start analyzing traffic. Let's go ahead. I showed you a minute ago the user agent. Okay.
Mm-hmm.
Let's go ahead and take a look at that. Okay, you can see here. And we can see that we have just 4 packets that have a user agent, right? These are the ones where let's go ahead and open up, click on one of them, and you can see here's the user agent right here. It's from a Linux system, right? And Mozilla. And so that's going to give us some clue as to where the traffic is coming from, right? But there's, to being able to go ahead and do an analysis, it's all of the analyses of an attack is going to be different. There's really, there's no single rule as to what's going to be taking place and how to analyze it. So you have to kind of first of all look at the traffic and look for anomalies. Now that raises a really important issue, and that is, how do I detect anomalies? Well, the way I detect anomalies is to know what's normal. If I don't know what's normal, then I don't know what is abnormal. An anomaly is abnormal. And so one of the things that I can do is I can go ahead and capture, okay, and get a picture, okay, of what my traffic looks like. So here's under statistics. I can go over here and go IPv4, okay, and then go all, let's go IPv4, go all addresses. And this is going to give me some statistics, right? And if I see, once again, let's go back to a DDoS attack or a DOS attack, we should see a lot of traffic coming from a particular IP address. But it's important that anybody who's using Wireshark or doing this type of analysis in their company, in their business, the first thing you need to do is you need to capture what is normal traffic. And you need to have some idea of what normal traffic looks like. If you don't have that, it's pretty darn hard to determine what's abnormal. So the first thing I would recommend is to capture some of this statistics. Here, it's by IP address. It's just telling us what's normal. Okay, it's telling us what's happened by IP address. We can also do it by protocol as well. So we can go statistics and then go IPv4 and go IP protocol types. Right? And it's going to tell us we have some UDP traffic in here, right? And we have some TCP, which is it's 77%, and we have something that is listed under none. Right. And so these are the type of things that, as a security analyst, you need to know before the attack, right? Yeah. Is what does my baseline look like? All right. Because all of this can look really confusing and look threatening if you're not familiar with what it looks like in a normal situation. So we can look for things like, say somebody was using SSH. See if there's any SSH. Well, there's none in this case, right?
I think what you mentioned on the baseline is extremely important, because that's the only way later you can spot the anomaly. And based on spotting the anomaly, I'm just summarizing what you said for the viewers. After you are spotting the anomalies, you can identify the endpoints. So you check the conversation or endpoints for suspicion IPs or unusual protocols, as you showed. Then you filter the traffic, filter based on the suspicious. You follow the stream. If you can inspect the payload of the stream, and then you export the object, the hash files, and correlate it with the intel of what you see. And it's not one only solution as Wireshark. There are multiple solutions that can correlate together to find the malicious act or the malicious point or the problem. Not all it's malicious.
Right. And so, as you said, you have to go ahead and first of all, create a baseline and be familiar with what that baseline looks like, what normal traffic looks like. And then this will help you to be able to focus on what's abnormal on your traffic. Right. Here's a simple filter for port 3389 or RDP. And RDP is being used by a lot of attackers in the wild right now. Mm-hmm. So this is maybe one of the things that I would look for. And of course, on my traffic, I don't have any RDP. But, I can put in any port in there and a TCP port, of course, right? And I get all my port 80 in here that's being, if I were looking, say, for like 161 for port for SNMP. I'm not going to find any because port 161 is a UDP port. And so I would have to go ahead and go UDP. And SNMP is a way that your network devices communicate with each other. So these are kind of things that you might want to be looking for. You can look for, say you were looking for, maybe somebody was exfiltrating through your mail server. You can go SMTP, right, and look there. We don't have any here. Or you could do it by TCP. So it's different ways of getting the same information. TCP port 25, which is SMTP. And look if there's any unusual traffic there.
Go. You know what? Go to a site, http example.com. That's the easiest.
Okay, let's do it. Okay.
Yeah.
There we go. Okay, we tried a few of them before. Let's go and look at the request.
Yeah.
Okay. Yes. Request method.
Yeah.
Right. In this case, we'll look at post. And there we go. We've got all of these posts, right?
Yeah.
And we can look for, let's look for get. The method is get. And we got a couple of gets there. We could go and let's go and look for HTTP URI. Okay. And let's go contains. Okay. And let's just, no, it still doesn't like it.
But if you put the double quote, try again.
Okay. Okay. And select. There we go.
See?
And so this what this would do is look for a select keyword from a SQL injection. We're probably not going to find any, but let's take a look. We don't find any.
Yeah.
We can go ahead and maybe look for a keyword like example, since this is on the example.com site. I'll spell it right. All right. And we don't get any of those either. So, and let's see what else we could look for here.
OTW, while you're looking, we are in the age of AI. Everyone are trying to automate their processes and analysis. Do you use today, maybe, or you teach part of your classes how to connect the Wireshark into AI systems?
I haven't done that yet, but we are using AI systems for a lot of different things. There's actually an AI system that can be used for penetration testing. And we're doing a number of different things. Mostly we're focusing a lot on defending with AI systems. So being able to analyze traffic, with an AI system, looking for bad traffic or traffic that might be malicious. And that is right now, I think, one of the most useful areas of AI is in being able to detect malicious traffic. So what I really like about this particular tool is just the idea that we can go through any one of these packets and just dissect them and get every bit of information that's possible on every packet except what's inside the payload if it's encrypted, right? And that we can't get if it's encrypted, but we can get all the other header information. And this can often lead us to where the malicious traffic's coming from and what type of malicious traffic it is, including whether or not it's, say, an ICMP, it's DNS, is it TCP, is it IP, is it SMTP? These are all the things that Wireshark can help us do. We can also use it to be able to determine if there's a problem on our local area network. Maybe one that's not created by an attacker, but instead by simply a misconfiguration of our local area network. And this will show up in Wireshark and it'll give us clues as to what's going on in our network and then be able to help us identify where the problem is. Let's see. Let me see if I can find a couple more that I want to show you. Let's see. We've done quite a few. Let's see. There's so many different filters that we can create looking for information. It's hard to cover it all in a single half-hour video, but you get the idea that we can create just about anything. Let's see what else we can do here. One of the things that we can also do, we can look for traffic, that's on our local area network that might be malicious. We can look for instance, whether or not there's a command shell exiting our system. We can look for the IP port. Let's see. Let's go ahead and look at TCP. Okay, this is one that, remember, we were using the contains keyword. So this is a little different. If we're going to look for, say, traffic that is coming with a particular keyword, so for instance, like hacker, is there? Obviously, that's not going to be a hacker, but let's see if we can find any. It's still not allowing me to use the contains. Let's try using it. Yeah, there we go. Oh, look at that. We have some hackers on our system. Actually, it's because we went to Hackers Arise. Right?
Yeah, exactly.
Right? So we found a hacker. So this allows us to be able to find keywords in our traffic that might be assigned. Obviously, here we've gone to hackers arise. So the keyword hacker is going to appear there. One of the things also, let's go ahead and clear this, and we can go ahead and go right click on a packet, and we can go ahead and follow the packet. So this allows us to follow a stream. And go ahead and just do, and it's going to show us the stream of packets, right? And we can, here you can see this is the entire conversation. And let's go through it all. Okay. And this is, it's 8 client packets, 6 server packets, and 10 turns. It looks like all of this is all encrypted. Right, but we still can find some information that might be helpful to us. Let's try some unencrypted traffic. Right, so let's go HTTP. Let's put that as our first filter. And we got HTTP traffic over here, and then follow the stream, and follow here, HTTP stream. And here we go. You can see we got some good information here, right? So it's showing us the GET request, the host, right? Other key information. And then we follow each one of the packets in the stream. And this is where we did the example domain. Right?
Mm-hmm.
And so this can be really useful to see the conversation, the request, okay?
Yeah.
And then the response, the request and the response between 2 endpoints, right? So we wanted to filter by those 2 endpoints and see the requests and responses. This is the way we can do it. And that's simply done by going ahead and clicking on a packet, right? And then right-clicking, and then go ahead and say follow, and in this case, the TCP stream. And you can see the TCP. It looks like there's only 3 packets in this case, right?
Mm-hmm.
So this is if you've identified one packet that looks suspicious, you can go ahead and just follow all the conversation that's been taking place between 2 endpoints by following the stream. See, I think that might be just about everything I wanted to show you. All right. So I just want to kind of finish up by saying that this is a tool that everybody should kind of get familiar with. Right? If you're not familiar with it, you should. And it can be a very powerful tool. I think if you're somebody who's out looking for your first job, you need to be able to use Wireshark, because it's probably one of those things that you're going to be questioned about in an interview. Can you use Wireshark? And can use it effectively. You might even test you to show you, you have to prove that you can actually use it. So, it's one of those, there's probably a half a dozen tools that everybody should know in cybersecurity, and this is one of them that I would include. Whether you're an attacker or a defender, you should be familiar with Wireshark.
Okay, so today we went hands-on with Wireshark, from spotting anomalies to filtering, following streams, and tracing what really happens inside the packet. It was a great mini tutorial with Master Hacker OTW. Thank you very much. And we have done many other deep dives together, me and OTW, so you can check it out on the channel. I'll put some on the screen, but definitely check all of the videos we did together in the group of OTW Mix. Don't forget to like, subscribe, and stay tuned for the next one. Thank you very much, OTW, and thank you very much for everyone who attended this session.
Thanks, Yaniv, and I hope that you'll ask me back again in the future.
Definitely.